Friends, today we'll learn about conversion of galvanometer into ammeter and voltmeter, right? So you know the operating principle of galvanometer, right? When current flows through a conductor, force is experienced on it, right? That is F is equal to BIL. And if coil is there, then force will be in both the sides. If one side is going up, another side will be going down. So there will be a torque, right? So today we'll be learning about conversion of galvanometer into ammeter, right? Students, galvanometer can measure very small amount of current, right? In the range of milliampere, let's say. Okay. So that means if I'll be taking a galvanometer, then there is a galvanometer, right? It can measure some amount of current, right? Some current, it can measure some current I, let, and this is let G is the resistance of the galvanometer. G is the resistance of galvanometer, right? Correct, student? It is the resistance of galvanometer. Let you are having NCERT book with you, students? Do you have NCERT book with you? Everyone just open additional exercise questions. Just open additional exercise questions, right? Let students, let any ammeter, let I'm saying you about a ammeter, right? Let this is an ammeter. It can measure 5 ampere, right? It can measure 5 ampere. So can I give 6 ampere to it? Can I give 7 ampere to it? No, I can't give 6 ampere, 7 ampere because its rating is 5 ampere. What is its rating? 5 ampere. Rating is 5 ampere means it can withstand maximum 5 ampere. Are you getting? Rating 5 ampere means it can withstand maximum 5 ampere. If I'll give more current, then what will happen? Student, there is a formula, heat is equal to I square R into T, right? What is it? I square R into T. If the current will increase, then you see H is directly proportional to I square. The device is having some resistance and the current will flow for a particular time. More time, more heat will be generated there, right? So here, if current will increase, then the heat will increase. And this device is designed, right? Inside an ammeter, there will be some coil. And the coil is having some resistance, right? So there is a particular point so that it can withstand some amount of current. If I'll be giving more current, then it will burn. More heat will be generated. So we can't give. Like that, later I'll be saying a ammeter, galvanometer. The resistance of galvanometer is having something. The rating of the galvanometer will be having something. I want to measure more current than that. Then what I have to do? What is the thing that we can use for opposing the flow of current? That is resistance. That is something that is resistance. Correct? That is something that is resistance. This is R. Resistance opposes the flow of electric current. It opposes the flow of electric current. Right? Resistance opposes the flow of electric current. So if I want, let's go to the question directly because we are here learning about conversion of. We're learning about conversion of galvanometer into ammeter. So let's directly go to a question. Then as per that question, we'll understand, right? So let's go to the question directly. From the question, we'll be coming to the concept. In question number 4.28, chapter 4, moving charges and magnetism, additional exercise, question number 4.28, there is a question given. A galvanometer coil has a resistance of 15 ohm. That means we have taken a galvanometer, students. The resistance of the galvanometer, let G, it is having the resistance as 15 ohm, correct? And the meter shows a full scale deflection for a current of 4 milliampere. That means the rating, the maximum current that can go through the galvanometer is 4 milliampere. Are you getting that? Right? Then it is asking how you will convert the meter into an ammeter of range 0.60 to 6 ampere. That means the current rating is given 4 milliampere. I can give more current to the galvanometer. I can't give the current more than 4 milliampere, right? But I want to measure. Actually, I want to measure how much current? 0 to 6 ampere. That means maximum current I want to measure 6 ampere. What I have to do? Students, see, what is the maximum current it can withstand? It can withstand a current of 4 milliampere, right? It can withstand a current of 4 milliampere. 6 milliampere to 6 ampere to this? No, it will burn because H is equal to I square T. So it will burn. Are you getting? Right? So what we have to do? That means, students, see, There are two things. You know, there is a connection, series connection, and there is a parallel connection also. That means if I will give 6 ampere current to this galvanometer, it will burn. If I will give 6 ampere current to this galvanometer, it will burn. Then what I have to do? Students, where the current divides? In which connection the current divides? If I will be giving I current, then the current divides in parallel connection, right? That means I can design something that this is the galvanometer. And the rating of the galvanometer is given how much, students? It can measure up to 4 milliampere. 4 milliampere means how much? 4 into 10 to the power minus 3 ampere. Very small amount of current the galvanometer can measure, right? That is 4 milliampere, correct? Yes or no? But I want to give how much? 6 ampere current. So what I have to do? Because if I will connect something in series, nothing is going to happen. Because in series, the current remains same. So I have to connect a resistance in parallel. And if 6 ampere current is coming, and I will design the resistance in such a way that current always chooses a path of low resistance. 4 milliampere current will go through the galvanometer. What is the extra amount of current? Now, sir, 6 ampere, 6 minus 4 into 10 to the power minus 3. Are you getting my point, student? 6 ampere current is going. The galvanometer can withstand a current of 4 milliampere. I can't allow extra amount of current to go through the galvanometer, right? So what I have to do to divide the current? I have to connect another resistance in parallel. Why? Because in parallel the current divides. In parallel the current divides. If I am giving 6 ampere, let the 4 milliampere to go through that. And the resistance of the galvanometer is also given 15 ohm. Right? It is given 15 ohm. And here, let the extra amount of current. What is the extra amount of current? 6 into 4 into 10 to the minus 3. Then we have to decide this resistance. Just same with the logic, students. The resistance of this will be less than 15 or greater than 15. Because if 4 milliampere current is going, very small part of the current is going through the galvanometer. And maximum part of the current is going through this resistance that we are going to connect. And it is connected in parallel. This is known as shunt. This is known as what? Shunt. So maximum current is going through flow through this. So definitely the resistance has to be less than 15 because current always chooses a path of low resistance. Are you getting? Current always chooses a path of low resistance. If current always chooses a path of low resistance, then this resistance has to be less than 15. Then how to calculate that resistance? See how to calculate. Student, this galvanometer is connected in parallel with this resistance, isn't it? So parallelly, what remains same? Voltage drop remains same. Just remember, in parallel connection, voltage drop remains same. And if the resistance is 15 ohm and the current going is 4 milliampere, then what is the maximum voltage drop across the galvanometer? That will be also equal to the voltage drop across this shunt. That means I can say voltage drop across galvanometer. Voltage drop across galvanometer will be equal to voltage drop across shunt because both are connected in parallel. Are you clear? Voltage drop across shunt. Are you getting, students? I can say voltage drop across the galvanometer will be equal to the voltage drop across the what? Shunt connected in parallel because both are connected in parallel. And how to calculate the voltage drop across galvanometer? Sir, V is equal to IR. How much current is going? Sir, 4 milliampere into 15. That will be equal to, let this resistance is R. R into, sir, 6 minus 4 into 10 to the power minus 3. That means we can write like this. 4 milliampere means how much? Or you can write it like this. 15 into 0.4 milliampere means 4 into 10 to the minus 3. 4 by 1000. 0.004 is equal to R into 6 minus 0.004. Is that clear to all students? Are you getting my point?
L square T
We're
by
already going to solve. So 15 into 10 to the power 15 into 0.004. So then R is going to be, students, see, 6 minus 0.004. That is 5.996, I think. If I'll add 0.4, then it will be something, right? Is that clear to all? Students, is that clear to all? Only 5.996. R is equal to how much? So R will not be in the, it will be in the denominator. R will be this side. Then 15 into 0.15 into 4 how much? 60. 60 divided by 1000. How much? 6 by 100. 0.06. Yes or no, students? So in the numerator it will be 0.06, and here 6 minus 0.5, 5.994. So that is going to be how much? See, 0.06 divided by 5.994. It is 0.04, so it will be 996. So you divide and you will be getting about approximately 0.01 ohm. Approximately it will be coming 0.01 ohm. That is 10 milli ohm. You can write 10 milli ohm. So what is the resistance that is to be connected? So to convert a galvanometer into ammeter, to increase the range, we have to take another resistance that will be connected in parallel, because the extra amount of current will be flowing through the resistance that is connected in parallel. And that should be very less, because maximum current is going to flow through the resistance. Current always chooses a path of low resistance, right? So this is the way how to calculate the extra resistance to be connected, or the sun to be connected in parallel for converting a galvanometer into ammeter. Is that clear to all? Let's understand how to convert a galvanometer into voltmeter, right? What's the way? So let's, in the same way, Ncert question number 4 point, that is 27, right? It is given a galvanometer coil has a resistance of 12 ohms. So that is a galvanometer, right? Let the resistance of galvanometer is taken as G, that is given 12 ohm, and it shows a full scale deflection of 3 milliampere. That means the current that can go through the galvanometer can measure up to 3 milliampere. And how you will convert it into a voltmeter of range 0.18 volt, 0 to 180 volt. We want to measure 0 to 18 volt. Student, now see, now let this is the galvanometer. As per the rate given data, it can, what is the internal resistance of the galvanometer, students? 12 ohm. How much current is flowing? 3 milliampere, right? I want to measure how much voltage. I'll be connecting a voltmeter over here, then it can measure how much voltage. It can measure, students, V is equal to I into R. I is how much? Sir, I is current through the galvanometer, and G is the resistance of the galvanometer, G. That is 3 milliampere, means 3 into 10 to the minus 3 into 12. That is 36 into 10 to the power minus 3. That is 36 millivolt. Are you getting, students? So it can measure a voltage up to 36 millivolt. Are you seeing, students? It can measure up to a voltage of 36 millivolt. But we want to measure how much? We want to measure 0 to 18 volt, right? We want to measure 0 to 18 volt. What to do, students? We want to measure it into a voltage of 0 to 18 volt. But अभी का जो situation है, इस पे 12 ओम इसका resistance 12 ओम है, और इस पे 3 milliampere current जा रहा है, right? अगर 3 milliampere current जा रहा है, उसका resistance 12 है, तो इस पे कितना voltage drop होगा ना सर? V is equal to IR. How much current is going and what is the resistance? Current going is 3 into 10 to the minus 3, and voltage and the resistance is 12 ohm. So 36 into 10 to the minus 3, that is 36 millivolt. But we want to measure, the desired value of measurement is 18 volt. What is to be done for that? Students, see, what happens? We can't connect something in parallel, because if you are going to connect something parallel, then the same voltage will be dropped also, it was there. So where the voltage divides in series connection. Remember, voltage divides. We have to divide some extra voltage, right? That means if I will connect another resistance, and this is the resistance of the galvanometer previously given, I don't know value of this, but the current will be remaining same, IG, and here also the current will go IC, and the total voltage drop, how much, students, here? 36 millivolt. But but it is required to measure how much voltage, students? How much voltage do I require to measure? 18 volt. मैं चाहता हूं कि ये पूरा 18 volt संभाले, right? तो मुझे यहाँ पर कितना रेजिस्टेंस लगाना पड़ेगा? Are you getting my point all? कितना वोल्टेज मेजर करना चाहते हैं? 18 वोल्ट, राइट? हम चाहते हैं कि ये 18 वोल्ट मेजर करे। और स्टूडेंट, अभी गैल्वानोमीटर का कितना करंट जा रहा है? 3 मिली एम्पियर। दैट मींस मैं चाहता हूं वोल्टेज कहीं पे दिया हुआ है 18 वोल्ट, और रेजिस्टेंस इज गिवन, और करंट इज गिवन हाउ मच? The maximum current, that is IC, is equal to given 3 milliampere. So what should be the resistance of the circuit? ना सर, R is equal to V by IG, right? और ये जो R है, कौन सा रेजिस्टेंस है? Not only this resistance, this is the combination of total resistance, that is resistance connected plus G, right? That should be equal to V by IC. Yes or no, students? So then if I want to calculate R, then R is equal to how much? मुझे कुछ extra resistance लगाना पड़ेगा, बट मैं चाहता हूं कि इसके थ्रू 18 वोल्ट मेजर हो पाए, जबकि इसमें कितना करंट जाएगा मैक्सिमम? ये सीरीज पे कनेक्टेड हुआ है स्टूडेंट्स, राइट? आई कैन डू लाइक दिस। मुझे यहाँ पर सीरीज पे कनेक्ट करना पड़ेगा, और सीरीज पे कितना करंट जा रहा है? 3 मिली एम्पियर। अगर ये पूरा 18 वोल्ट मेजर करता है और इसमें 3 मिली एम्पियर करंट जा रहा है, तो इसका रेजिस्टेंस कितना होना चाहिए? टोटल रेजिस्टेंस। टोटल रेजिस्टेंस मतलब मैं चाहता हूँ कि इस पूरा के एकरस में 18 वोल्ट ड्रॉप हो, राइट? 18 वोल्ट शुड बी ड्रॉप इन द टोटल। सो इसके थ्रू कितना ड्रॉप हो रहा है? 36 मिली वोल्ट। ऐसे आप सब्सट्रैक्ट कर सकते हो 18 से। बट अभी क्या बात क्या है कि ये आर मैंने लिया, ये जी, आर प्लस जी कितना होना चाहिए? टोटल वोल्टेज 18 डिवाइडेड बाय टोटल करंट, राइट? तो आर इज इक्वल टू हाउ मच? 18 बाय 3 मिली एम्पियर, दैट इज 3 इंटू 10 टू द माइनस 3 माइनस कितना है रेजिस्टेंस गैल्वानोमीटर का? 12 वोल्ट, 12 ओम, राइट? सो 18 मतलब 6 इंटू 10 टू दी पावर माइनस 3, ये ऊपर जाएगा तो प्लस हो जाएगा, 3 18 जो 6 हो गया, 6 इंटू 10 टू द प्लस 3 माइनस 12, राइट? सो दैट इज 6000 माइनस 12। देखो क्या होगा, कितना होगा? 6000 माइनस 12 कितना हो जाएगा? 5988, राइट? 5988। एक चीज आपको याद आ रहा है, इससे पहले हमने जो क्वेश्चन किए उस पे हमने पैरेलल पे बहुत छोटा सा रेजिस्टेंस लगा जिसका वैल्यू बहुत कम था, और यहाँ पर हम सीरीज में हाई वैल्यू ऑफ रेजिस्टेंस लगा रहे हैं, क्योंकि जब एमीटर एमीटर का इंटरनल रेजिस्टेंस हमेशा क्या होना चाहिए? कम होना चाहिए, राइट? अब और ऐसे भी जब मैं दो रेजिस्टेंस को पैरेलल पे लगा रहा हूँ, नेट रेजिस्टेंस कम हो जाएगा। और वोल्टमीटर का इंटरनल रेजिस्टेंस क्या होना चाहिए? हाई होना चाहिए। क्यों वोल्टमीटर का इंटरनल रेजिस्टेंस हाई होना चाहिए? क्योंकि ये पूरा वोल्टेज मेजर करता है, और जब ये पूरा वोल्टेज मेजर करता है तो रेजिस्टेंस ज्यादा होना चाहिए, क्योंकि V इज इक्वल टू आई एफ, तभी जाके पूरा वोल्टेज उसके एकरस में ड्रॉप होगा। और एमीटर का इंटरनल रेजिस्टेंस कम क्यों होगा? क्योंकि मैं चाहता हूं कि मैक्सिमम करंट एमीटर के थ्रू जाए, और मैक्सिमम करंट जाने के लिए एमीटर के इंटरनल रेजिस्टेंस क्या होना चाहिए? आइडियली बहुत लो होना चाहिए। दैट्स द रीजन। तो इसीलिए जब हम पूरा दिमाग पे इस क्वेश्चन दोनों को फिक्स कर दो, राइट? कोई भी क्वेश्चन आ सकता है इसमें, राइट? तो जब हम कन्वर्ट कर रहे हैं गैल्वानोमीटर टू वोल्टमीटर या गैल्वानोमीटर टू एमीटर, जब एमीटर बना रहे हैं तो वेरी लेस अमाउंट ऑफ रेजिस्टेंस इज कनेक्टेड इन पैरेलल, ताकि एक्स्ट्रा करंट उस पर चला जाएगा। जब आप वोल्टमीटर पे कन्वर्ट करना चाहते हो तो सीरीज पे एक रेजिस्टेंस लगाना पड़ेगा, क्योंकि जो एक्स्ट्रा अमाउंट ऑफ वोल्टेज है वो उसके थ्रू ड्रॉप हो जाएगा। तो दिस द मेथड एंड दिस द वे हाउ टू कैलकुलेट, राइट? जस्ट नोट इट।